And as a little bit of background, the Minnesota Compost Council has been around since 2012. It is a state chapter of the U.S. Composting Council, and we are dedicated to the development, expansion, and promotion of the composting industry based on sound science and principles of sustainability and economic viability, which is partly why we're having this webinar on compost use. This is our board of directors. There are 12 of us. 2 of them are retiring, Lynn and Shannon, and we want to thank them for their expertise in being on the board and helping us get through many, many different issues that relate to what's going on here in Minnesota. And we have 2 new folks starting, Nathan Reinbold and Dustin Monty. So we are excited to have them. They're composters here in Minnesota, and we are very, very excited to have them as part of our board. I also need to give a special thanks to the Market Development Committee, who has worked very hard to pull this together and worked for many months. We will be working again in the future here, because this is a first of 3 series. We have a very active legislative committee. We're forwarding some legislation on compostable products labeling here this year. And all of these other committees are quite active periodically throughout the year. International Compost Awareness Week, many of you are familiar with that. It's a foundation, composting foundation program, and we pair that here in Minnesota with our Plate to Garden, which is a program we started a number of years ago to educate folks on what happens to their food waste when they recycle it. And most folks don't really realize what it turns into. So it's always kind of a fun thing to see those faces be amazed at what happened to their food waste. As I mentioned, this is the first in a series of 3 webinars to be put on by the Minnesota Compost Council. We have not decided on official dates or topics, and in fact, you will play an important role in the topics we select, as we will be polling you for that eventually here during the webinar. But the dates, we don't have specific dates, but we've selected basically the end of February, the beginning of March as the time period in which we want to do the second webinar. And the 3rd webinar, we're looking at the middle of July, basically. As I said, the topics will be announced. We will be publishing our next newsletter at the end of December. We do a bi-monthly newsletter, and we will have that information in that, at least for the second webinar, in that newsletter. So look for that. All our speaker presentations are pre-recorded. The speakers will be available for question and answer after their presentation, their recorded presentation. And we also have, so don't worry if you don't get your question answered or you think of something after that, we will have a Q&A session at the end of the webinar as well. We ask that you use the Q&A feature on your bar at the bottom of your screen to submit questions. It helps us. There's some features that we get with that. It helps us answer your questions in a timely manner. This session is being recorded and will be available on the Minnesota Compost Council's website afterwards. And there will be a series of 3 quick polls. You're probably getting one right about now, asking you, who you represent and what your responsibilities are for composting within your organization. We hope that you will take some time to answer those questions. They're pretty quick ones. They're multiple choice for the most part. You can type in the chat box if you wish. So if you have something other than a question during the webinar, we ask that you use the chat feature. So if you want to pass along a web link that you think might be helpful to people, or some other piece of information, please use the chat box as opposed to the Q&A feature that you're using for questions. We absolutely have to thank our sponsors. They have been wonderful, and they are sponsoring all 3 webinars. So you will be seeing a slide with those folks listed here off and on throughout the webinar. And also, we have to thank our speakers for sharing the knowledge and wisdom that they have acquired in implementing their programs so that we can all benefit from that information. So our speakers today are Greg Thompson from the City of Eagan. He's going to talk about soil management for stormwater volume control. Kayla Fisher, the solid waste manager from the City of St. Louis Park, and Joe Schmala, an engineer for St. Louis Park, will talk about organics, their organics program, and how they use organics in their city. And Chuck Joswiak is the sales and marketing director for SET, which is one of our largest composters here in the state. And he will be talking about food for thought and necessary organics. So we're going to, let's see, stop sharing. And I'm going to bring up let's see. I can, there we go. There's Greg. The poll keeps getting in the way here. All righty, there we go. There we go. Greg is a graduate from South Dakota State University in 1994. He provides technical assistance to support reduced stormwater runoff impacts on water resources through the land projects and water projects in the city. Originally from a farm in South Dakota, he began his fascination with soils and vegetation and water. His background is in landscape architecture with over 30 years of experience in working in residential, commercial, and agricultural and public land projects. So, let's see here. Get out of the way. I have to, wait a second. Boy. Can you hear?
Hi, I'm going to talk about soil management for stormwater volume control. My name is Greg Thompson. I work for the City of Eagan. I'm a watershed specialist at the city. Trying to get my slide to advance. Okay, so at the City of Eagan, I provide technical support to reduce stormwater runoff impacts on priority lakes through land projects. So that includes public projects.
You're not seeing this video.
That I do.
What happened?
So if redevelopment projects, new development projects, if it's triggering our stormwater post-construction stormwater rules or land disturbance rules, then I get involved on checking.
I hate this.
Do you want to pause and stop sharing your screen, and we will see if Linda can pull it up?
I'm trying to do that.
Okay.
For, you know,
the poll was getting in the way. That was my problem. I couldn't see stuff. Okay. Now can you see it now?
Yes, we can.
Okay.
Drag it back to the start. Yep, perfect.
All right. Yeah.
Hi, I'm going to talk about soil management for stormwater volume control. My name is Greg Thompson. I work for the City of Eagan. I'm a watershed specialist at the city. Trying to get my slide to advance. Okay, so at the City of Eagan, I provide technical support to reduce stormwater runoff impacts on priority lakes through land projects. And so that includes public projects, but also private projects that I do development review. So if redevelopment projects, new development projects, if it's triggering our stormwater, post-construction stormwater rules or land disturbance rules, then I get involved on that for checking through their plans, making sure they're in compliance. And then I'm also involved in watershed stewardship activities, including public education. On development sites, we're used to the impervious surfaces being streets, sidewalks, driveways, rooftops, parking lots, things like that, asphalt, concrete, stuff like that. But on a lot of development projects, we're getting a greater appreciation for the impact of graded and disturbed soils that just get compacted during construction grading activities and then get revegetated over the top without really working these soils back again or improving these soils, bringing organic matter back into the soils. So what often happens, these sites get revegetated on super compacted subsoils, mineral soils, sand silts, clays that are just super compacted. Root growth can't push into that. It's too compacted. And then it gets vegetated, and then you get a rain event, and there's just a lot of runoff off of this. Water can't absorb into the ground anymore. So we call that green concrete when they drop sod on top of this, roll it out on super compacted subsoils. Absorbs a little bit of water into the sod itself and then saturates it like a 1/4 inch, and then everything else is running off in a rain event. So comparing natural soils to compacted soils, my picture thing there. So it is typical on a natural soil organic content 5 to 8%. You have less than 50% is mineral soils, air pockets, moisture within there, water within there. So low bulk density, low weight, a lot of pore space within natural non-compacted soils compared to compacted soils. That just gets scrunched down. Topsoil gets stripped off, so very low organic matter within that soil, high amounts of mineral soils, so sand silts, clays. That results in higher bulk density, higher weights, less pore space. On the left is a 5% organic matter, but a soil would look like a black topsoil compared to a 1 to 2% soil organic content, which we often see we used to see more of on construction sites of this is what it looked like right before they rolled sod out on it or seeded it and put erosion control blanket or hydromulching over the top of it, but horrible growing conditions for plants. Low organic matter, super compacted. Checking out soils, we use heavier duty soil augers to go in or soil cores if you can physically get it into the soil. Sometimes we're extract out a 1-inch depth sample because the soils are just too hard. Send it to the lab, you get soil test results back. We're mainly looking at organic matter and pH. The organic matter, in this case, this is off a construction site. Before they did any soil improvements, we try to go in and do a pre-analysis. So 1.7, and that's pretty typical, 1 to 1.5 to maybe 2.5, in best situation for the remnant soil that's left over after grading. Testing for soil compaction, we use a penetrometer, is one device. So that gives us readings in PSI. So you're pushing it in at an equal pressure and then taking down notes on where the gauge is on PSI. But below 200 is good growing conditions, so no restrictions on root growth. 200 to 300 PSI, fair growing conditions, it's sort of impaired root growth, and you get 300 PSI and above, poor growing conditions, or really no chance of root growth into something that hard. Bulk density sampling, we use a soil core sampler. This is a slide hammer that goes on a bulk density. And we do this sometimes, but you collect the sample, a known volume, and then dry it out in a microwave and then weigh it to determine the bulk density. So for bulk density comparison, so an undisturbed soil, so sandy soils, silt loam, clays, those are all in the right around 1 grams per cubic centimeter, compared to an urban condition, so bulk density on that of the maximum density for root penetration is 1.6. Concrete pavement is 2.2. So this was a table that was put together by Tom Schuler, who was at the Center for Watershed Protection at that time, of doing a literature review of a lot of soil studies. So what they're seeing is urban lawns, urban fill soils, athletic fields, all in that, really close to 2, close to concrete on average. Effective compaction on soil infiltration rate. Sandy soils naturally can infiltrate over 10 inches per hour, but you compact it and it's down to 0.5 or 0.2 inches per hour. Clay soils, undisturbed with organic matter and root systems in there, can naturally infiltrate 9 inches of water per hour, but you compact it and then take out that organic matter, then it's down to 0.2, down to 0.02 inches per hour. So it doesn't take much of a rain event to just overwhelm this, and then you just get a lot of runoff. So as we add runoff, or impervious surfaces, so rooftops, parking lots, driveways, streets, plus compacted subsoils underneath revegetated areas that have been graded and really highly compacted and disturbed, that's all impervious, effective impervious. And so the more impervious, the more runoff we have, the less water we have going into shallow groundwater and aquifers. Can urban soil compaction be reversed? This is also literature review done by Tom Schuler of a lot of studies that have been done previously. So they're showing tilling of soil, decreasing bulk density, really no chance of decreasing bulk density, because if you're not amending it with some organic matter to keep it sort of open from sealing back up again, it'll just seal back up. Down to then compost amendment can be a significant a way to reduce bulk density, because it just creates this sponginess sort of to the soil in one way. There was a study done by Nicholas Olson and John Gulliver at the University of Minnesota St. Anthony Falls lab about 10 years ago on remediating compacted urban soils with tillage and compost. They worked on sites within the Three Rivers Park District on different lawn areas, took over 1,000 measurements over 2 years, and they had a control plot and then a tillage and compost amendment plot. And what they were finding is that the permeability of the tillage plus compost plots was 3 to 6 times that of the control plots. And the permeability was always higher in the tillage plus compost plots than it was on the control or till only plots. In the city of Eagan, this is what we're shooting for a healthy soil goal for redevelopment or new development sites on their graded areas to be revegetated. We want loosening down to a 12-inch depth and amended to a 5% soil organic content in the top 6 inches of soil. So we want it looking black before they try to revegetate it. For determining the compost volume needed, we have used a calculator, an Excel spreadsheet that got out of Washington State that was publicly available. We put in our knowns, bulk density, organic matter, initial organic matter, our targets, bulk density of the compost being brought in, the soil organic content of the compost being brought in, the depth to be amended, and then it gives us the depth of compost to be applied. We put in our area to be covered. It gives us the volume. You can put in a unit cost to get your total. But what we've sort of settled around is around 50 cubic yards per 10,000 square feet using MnDOT 3890 grade 2 compost. So that's with an assumption that the construction site is going to have 1.5% soil organic content that's just going to be occurring in that soil. So on Egan sites, this is in our stormwater management rules that we put together in 2015 or revised. So sites with 10,000 square feet or more of land disturbance involving impervious surface installation for their volume control options, they can choose to do nothing with the soils, but then those soils are counted as impervious surface due to soil compaction impacts when they're planning their volume control practices. And then they have an option of then including soil management strategies to implement or remediate soil compaction and improve organic content on disturbed soils. And if they do that, then those areas that are graded and disturbed to be revegetated don't count as impervious surfaces. And then they follow standards in our engineering standards manual. For rate control, if they choose to do nothing with the soils, then they have to use a minimum curve number of 84 in their modeling for post-construction conditions. Or if they include soil management strategies, then they can justify using a lower curve number. Usually we'll go no lower than 64, roughly, for a curve number, and then follow the standards in the manual. So in our manual, then we describe what the goal is of the engineering or the soil management strategies to improve soil quality and permeability, and what the applicant shall do, and then what our measurements are. So we want no less than 5% soil organic content in the top 6 inches, and then soil compaction testing numbers, where it should be at for bulk density, for using a penetrometer, or it's if they can take a wire flag, a 12-inch long wire flag, like a utility locate flag, using one hand, push that into the soil to a 12-inch depth. If you do that, that's around 200 PSI, and so then we're good on that. And these are the notes that we provide to the engineers, the private development engineers, to put into their plan sets, into the grading plan, into the SWIP plan, the phase 2 plan, and then into the landscape plan, because we want to make sure all contractors involved are aware of this, that are involved with anything outside on the construction sites. So it includes what we are going to be asking for, that it's got to occur prior to the installation of any irrigation system, trees, shrubs, sod, or seed, what the requirements are: 12-inch depth of loosening, 3-inch of grade 2 compost, although we'll accept the 50 cubic yards per 10,000 square feet, how we're going to measure it, and that they need to provide us 24 hours notice to arrange inspections and talk about it. For residential subdivisions, then the developer is responsible for the overall common areas, and then as homes are built, if they're by different builders, then those different builders are responsible for their own lots before they're given a certificate of occupancy. What we're often seeing now is separate plan sheets that are the soil management plan that shows the areas to be amended. And then there's also, we're requiring them to include the area to be amended and the volume of compost to be imported and be incorporated. We also require that to be included on the SWIP sheets where they put their quantities for BMPs. So the contractors, the grading contractors typically that are bidding on these, know that quantity so they can be fair about the bidding on it, and nobody's surprised when we say, nope, we really do want you to implement those soil requirements, because oftentimes those are looked past. So for the actual practice, soil ripper and scarifier, this is skid loader mounted rippers. Works very effectively, goes down to about 12 inches. You can adjust the teeth. They rip through first for the construction impacts, and then add the compost, and then rip again to incorporate that. So these are available from our local rental center. There's also, this is a heavier duty ripper that I really like. It's thick steel. These can go down to 18 inches in depth. So first they start off a little shallow. If it's really compacted, make a few passes, drop the teeth and go a little further, rip it open, and then put the compost on and then rip that in. We say scraping doesn't count. We want it deeper. They would not get their certificate of occupancy if this is all they did. And for big or urban sites, this is too big of a piece of equipment, of agricultural equipment. So the process, loosening, rip parallel with contour, spread the compost, rip to incorporate compost, level it, then vegetate it. This is what we want to see. We can check it with a core, use the wire flag to sink that all the way down, measure it with a penetrometer, but in some cases we're just doing wire flag and doing some cores, and just there's also nicer penetrometers and nice mapping. We're also doing text inspections. A lot of the times contractor provides us with their testing results from the vendor before they bring it to the site. They send us a video of the ripper at full depth. They send us photos of compost application and then pictures of their haul tickets. There's good standards out there for sampling. And that's it. This is my email address. Feel free to use it and I'll respond back best I can. If you have any questions, let me know. All right, thank you.
Yeah, please type your questions in the Q&A and Greg can answer those for you, if you would. And here is a second poll that we'd love to have you answer, because the information you give us will really help us decide what we're going to do next with our next webinar. So here's a question. Greg, what has been the response from the contractors and specifying engineers?
Initially, we got a lot of pushback, but it's gotten better. Every year it's gotten better. And now we're just seeing it, yeah, not a lot of resistance to it. Yeah, it's been good.
Yeah, anything new is always kind of hard to
Yeah. But we explain it. We get more pushback from the general contractors than we do from the grading contractors. But then when we can talk with the grading contractors directly, they're, oh, okay, I see what you're trying to do.
Yeah. The next question was, what year did you start this program?
In 2015.
Okay, there you go. What were the reasons for pushback? Well, you just kind of explained that.
It was, different. They said it's not possible. You're gonna sink vehicles, out there in these areas that have been loosened. And having the farming background that I do, then I felt like I could respond better to that with some of the grading contractors or general contractors. But yeah, and then for us, it would really help of having, there's a Girton site that's in Egan that has compost. They also rent equipment, trailers, stuff like that. We talked them into purchasing some of these rippers to have them available for contractors to rent. So they did that, and I think that has just dropped a big barrier. It was having the proper equipment. That's what a lot of contractors were facing. And the equipment, the skid loader mounted rippers are relatively inexpensive. They're between $1,000 and $2,000. So some contractors very early on sort of saw this as coming in other places, and Carver County also has some similar rules. So we've had a couple that have now purchased their own rippers because they said they're using them more.
Okay. Another question. Yes.
I have a question going off of that. Could you talk some more about renting local equipment companies? Like, is it difficult for contractors to find the equipment they need when they need it?
Well, in Egan, Girton's is the only place that had a ripper, and they had initially just one. And so there were some cases where it was checked out and another contractor wanted it. And so then they would start coordinating between themselves. But then Girton's picked up a second one to make that available. But as far as I know, it's the only place that has these types of rippers available. Like tillers, they don't go down deep enough. Tillers go to like 6 inches and then often create another hard pan, where a rotary tiller sort of stops. So we really like this style of ripper, but we have had a few contractors that have now picked up their own, and one of the contractors was then renting it out to other contractors too. But I think at Gerton's they're charging like $60 for 4 hours. I mean, it's pretty cheap, and $100 or $120 for the day or something like that. So some contractors are picking it up and just holding on to it for a week. So.
Okay. Other questions, John? We have for amending soils, do you allow soil blends that include compost or just straight compost? What percentage of compost needs to be in the soil blends if you allow that?
Yeah, we've accepted the soil blend. Some of the, I'm trying to remember now, the MnDOT numbers, 38, 77, something, different letter codes behind them. We accept it as what our target is to hit that 5% in the top 6 inches. And as long as they hit that, we're okay with that.
Okay. Yeah. Have you had requests from other cities to replicate your standards?
Could you repeat that? I lost the audio on that.
Have other cities asked about your standards so that they can implement them?
Yeah. I've made presentations in a number of cities or sent presentations to them. I know Vermilion River WMO was talking about requiring that, and that would cover a bunch of cities. Yeah. So
okay.
Yeah, I love fielding questions. I love to talk about it. I like to hear if anyone has, sees any negative side of it. I'd love to.
We're going to have to move on pretty quick. I believe you are able to answer the questions that are in the chat. That was one of the reasons why we wanted to use this. You could type in.
Oh, okay. Sorry. So, I will click on that.
The rest of the questions, you can kind of work on that while we move on to the next group to speak.
Thank you.
Yeah, thank you. Thank you very much. Very interesting. Let's see. Our next speakers are, they're a pair. We get a duo here. Kayla Fisher from St. Louis Park, the solid waste manager, and Joe Schmala, the city engineer. They will be talking about developing city policy, compost derived from the city's curbside collection program. So they're trying to use compost that is not just yard waste, but food and yard waste. Kayla is the solid waste manager for the city of St. Louis Park. She oversees residential recycling and organics recycling programs for the city and has served in similar roles at the county and regional level for both Florida and the state of Minnesota. She has worked with commercial composters, haulers, educators, businesses, schools, and residents to expand organics recycling and promote the use of compost. Kayla is a graduate of St. Cloud State, and she majored in environmental studies. And I'm going to read the introduction also for Joe, because they're a pair and we can just have them work together. Joe leads the public engagement, design, and construction of multi-million-dollar public infrastructure projects. In 7 years with the city of St. Louis Park, he has overseen the construction of over $50 million of infrastructure. He has also led award-winning projects receiving awards from the American Public Works Association, City Engineers Association of Minnesota, and the American Council of Engineering Companies. Prior to joining St. Louis Park, he worked as a consultant for years for the city of Chanhassen, for 3 years for the city consultant for 3 years, and for the city of Chanhassen for 7 years. There we go. A graduate from the University of Minnesota, Joe holds a degree in civil engineering and is a licensed professional engineer in Minnesota. When not hard at work delivering quality projects to the residents, Joe enjoys fishing, traveling, coaching youth sports. So now we're going to bring up Kayla's presentation first. And have her give her pre-recorded presentation. Oh, wait. Stop sharing. Share screen. There. There we go.
Good afternoon. Thanks so much for having me here to speak about our organics program and compost use. My name's Kayla Fisher. I'm the solid waste manager for the city of St. Louis Park, and I will be speaking to you about our program, and you'll also be hearing from Joe Shamala, our senior engineering project manager for the city, on how they've used compost in projects this year. So for a bit of context, and for those who may be less familiar with the city, St. Louis Park is a first-ring suburb that covers roughly 11 square miles in Hennepin County. The city has a long-standing organized collection program for single-family households in 1 through 4 unit buildings, which provides collection for garbage, recycling, yard waste, and more recently, organics. The city's organics collection program began toward the end of 2013 and provides collection for food scraps and other compostable materials that are delivered to specialized environmental technologies composting facility, where it is mixed with yard waste and processed into SSOM compost, or source separated organic material compost. You'll hear us mention that term throughout the presentation. Of the 12,300 households that the city provides collection for, about 4,600 households are participating, so around 38%. And over the course of the year, they divert approximately 60 tons of material each month from the trash. The city also operates 5 organics drop sites. One of those is seasonal for residents in apartments, condos, and townhomes that don't receive city collection service and don't have access to organics at their homes. In addition to collecting the material, the city has worked to bring the resulting compost back into our city by providing it to residents for use in their lawns and gardens in limited amounts. Our contract with SET provides for a set amount of compost to be provided to us and given to our residents at no additional charge. In addition to just providing compost to residents, we've really worked to try to help them understand the connection between diverting that material, putting it out in the cart, and the fact that it is created into compost that can be used in their gardens and lawns. We, pre-COVID times, had the opportunity to put together workshops to provide that education, and then put everybody in a bus with no face coverings on and bring them down to the facility to actually see the process firsthand, have the opportunity to bring back a bag of compost and literally put their hands in the compost and smell it, see it, which is really a great experience for folks who were able to participate in that. In the last couple of years, we started looking for other ways to support compost markets in city projects through actually purchasing SSOM. We knew that we needed to expand beyond giving away compost to residents for free and support the markets through buying SSOM compost at market rates, much like we support recycling markets by purchasing recycled content printing paper. So in late 2019, I had a conversation with Joe, who you'll be hearing from in just a moment, about using SSOM compost in upcoming city engineering projects. Joe is going to provide more detail about the process and lessons that they've learned over the last 9 months.
Thank you, Kayla. We will take questions at the end. I'll just go directly to Joe's presentation.
A senior engineering project manager for the city of St. Louis Park. One of my responsibilities with the city is to maintain our specifications for road construction projects. In St. Louis Park, we take a thorough look at our specifications once per year and make changes for improvement. Here's a little background to help you understand the type of topsoil which has been used in St. Louis Park. Up until 2016, St. Louis Park used the loam topsoil as defined in MnDOT specifications. So why did we change? We were having issues keeping the sod alive on our road construction projects, and we were having to replace a lot of dead sod. One of the items we noticed when we took a closer look at the specification was that loam topsoil does not require the use of any compost. One of the questions we had was, is the organic content of the soil we were using too low? In 2017, we took a closer look at the MnDOT specifications and decided we were going to try a different topsoil called Boulevard topsoil. Boulevard topsoil consists of 1/3 loam topsoil, 1/3 sand, and 1/3 type 2 compost. This can be source separated organic material food scrap compost or compost made from leaves and grass clippings. One thing we noticed with the Boulevard topsoil is the high sand content. Some residents complained that the topsoil we were installing was too brown, and they were concerned that it would not support the newly installed sod. So how did we make the transition to SSOM food scraps for the compost in our topsoil? Kayla and I met about a year ago to discuss the use of SSOM on our road construction projects. We were both interested in finding a way to be able to use the compost, which was created by food scraps of our residents, and turn it into a product that we needed on our road projects. After initial discussions and reflection, it was time to modify our specification to use SSOM compost in our topsoil. So how do we inform the contractor who is bidding on our projects the requirements of our city? It is through the specifications. A little background information on how many cities and counties put together their specifications. MnDOT put out specifications which can be used by anyone doing road work in the state of Minnesota. As part of the contract documents, engineers put together plans and specifications so that the contractor understands exactly what they are going to provide for each item that they will be paid for. Cities and counties usually use MnDOT as a guide and supplement the MnDOT spec or modify them as they feel necessary to get their desired outcome. MnDOT defines grade 2 compost as derived from the decomposition of leaves, yard waste, SSOM, or a blend. If an agency is interested in ensuring that a contractor uses SSOM from organics, their specification must be updated to specify the requirement, as the contractor could meet the grade 2 compost specification without the use of food scraps. The city wanted to ensure that the compost which was being generated by our residents was being used to create topsoil for our road projects. The current MnDOT specification allows the use of food scraps in the compost, but does not require it. In St. Louis Park, our main use for SSOM compost is to create topsoil, which is then used on our road projects. Currently, we use 30% SSOM compost in our topsoil blend. A question which you may be thinking about is, has the city used the new topsoil spec on a project, and how is it working? The first project which used the new topsoil spec was the Walker Lake Reconstruction Project, which was finished in October of 2020. The preliminary results are showing signs of success. The contractor let us know that it was easy to work with for installation. We will be taking a closer look at this in the spring to see if the sod is looking good. We will also determine if we need to make any adjustments to the blend. So what have we learned so far about the use of SSOM in our topsoil? We've learned that the specs need to be clearly written so that contractors provide exactly what you are looking for. As an example, we bid out 2 projects with our modified specification in 2020. Our goal was for the contractor to use the SSOM from food scraps. Due to the definition of SSOM and the 2018 MnDOT specification, we were unable to hold the contractor to providing compost which was generated by food scraps. One of the projects in 2020 brought in compost from Specialized Environmental Technologies, or SET. The other project brought in compost, which was made using only yard waste and grass clippings. Both projects met the specification. How do we prevent this from happening again? We needed to update our spec. The city clarified the source of the organic material which can be used for compost. Contractors now have two choices, SET or Shakopee Midwakiton Sioux Community. Clarifying this in the specifications makes it clear that the contractor must provide the SSOM food scraps compost to create topsoil for our road projects. What are the future plans for the city? First, we need to see the results in the spring. This was the first year we used this type of blend for topsoil. So far, the SSOM blended topsoil is working well. In 2021, all of our construction projects will be using SSOM from food scraps to create topsoil. This will more than double the amount of compost we used on our projects this year. Another item we will be looking into is the amount of compost which can be used within the topsoil blend. We are hopeful that we can modify our current blend to include more SSOM compost. Instead of using 30% in our blend, maybe we can use 40%. Maybe we can use no more. We will continue to do adjustments until we find the blend which works best for our city. I'd like to thank you for letting us present this information today. Kayla and I would like you to let us know if you have any more questions regarding this topic. We would be happy to share any information or knowledge we have. Please reach out to us using the contact information shown on your screen. Have a wonderful day.
Thank you to both Kayla and Joe, and we'll take questions from our participants. I was just looking at how many people are attending. We have 114 people on the webinar today. So that's pretty amazing. One of the first questions I got is your spec only SSOM food scraps compost, or is it SSOM compost which includes food scraps as a constituent of the feedstock?
It is the SSOM blended with yard waste. So it's what's available at SET or at Shakopee Midwakiton Sioux Community.
And I would imagine part of the reason for that is that the food scraps have a lot of nitrogen. It has to be mixed with carbon when they're doing the composting to get that mix that they need at the facility. So pretty much all food scrap compost would have some kind of a carbon component to it, whether it's leaves or wood waste or something. And maybe we can have Chuck speak to that a little bit when he gets on, because he operates that facility. The next question I had is St. Louis Park. Oh, wait a minute. It sounds like your compost requirements are only for road projects. Do you have soil requirements for development projects? If not, what is that coming in the future?
Maybe Kayla can answer that. I know this is pretty new for us. We just started this like 9 months ago. So I think we kind of wanted to see where that started, but maybe Kayla can answer that.
Yeah,
Okay.
I'd be happy to shed a little light on that. Right now, we don't, to my knowledge, we don't have any other requirements for development projects. We do have some goals, though, that are listed in the city's climate action plan to eventually require the use of compost in development, both public and private development projects. And I know that our sustainability division is working on a green buildings policy with our community development folks, and compost use in those development projects is part of that discussion. So we're hoping that it expands, but like Joe said, we're early on in incorporating it in projects throughout the city.
Okay. I have a comment here from Dwayne Stenlin, who is with MnDOT. We worked many years together on these kinds of things. And he says his favorite blend is using 50% on-site soils and 50% of compost. The goal is to preserve topsoil, minimize cost of shipping, and maintain site conditions. So just a comment from Dwayne. We have another question here. If the final compost is of equal composition, can the compost be made using food scraps that are facility separated instead of source separated? Okay, so it would be, I would assume that's separated from mixed municipal waste if it's separated at a facility instead of at the curb. I don't know that you guys can really answer that one.
Yeah, it's not happening for, obviously in our area right now. So yeah, I don't think that's one that we could answer.
Yeah, all I can say to that is in the past, Minnesota has had a very long history of composting, and we started in the 90s in separating organic material from mixed municipal waste collected at the curb. It was so contaminated that eventually just went by the wayside, and we went to source separated because it's cleaner. And I'm not sure that answers that person's question, but hopefully it gives them a little insight into at least where the state of Minnesota has been over the years. I don't see any other questions at the moment.
Jenny, we do have a couple more questions here. This one
okay.
says, have you found thus far that there are less watering and therefore less staff costs needed or needs to reestablish that vegetation?
Because it's so new, that's going to fluctuate on a yearly basis depending on the amount of rainfall. So it's hard to know right now. But it is something that we will be monitoring a little closer as we get further into it. We only had one project that actually used the compost in it this year, and now next year it'll be all of our road projects. So it'll be a lot easier to kind of see from a citywide level how it's performing and things that we need to do to adjust. So.
Awesome.
And if I can jump in, Michaela.
Oh, yeah.
Oh, sorry. I was just going to jump in. A colleague is on the webinar as well and made a good clarification for me on the question about compost use in developments. Compost has been used in amending soils and developments for some time, but really our focus is on trying to find more places to use the SSOM compost and make sure that because we're separating the material, asking residents to separate the material at the curb, that we are then using that compost as a city. So my comments about it not being used yet is really in reference to the SSOM compost, which we're trying to increase. So just a quick clarification.
So the city is really trying to complete the loop, basically, the full recycling loop, in that it's collecting the material, composting it, and then bringing it back and actually using the product is kind of the concept that you're operating under, I get here.
Exactly.
Okay. Were there other questions, Michaela?
There is one more question, and it is, did contractors mention if their costs were higher due to this new requirement?
So we've taken a look at the cost that we received in the past and compared them to the cost we received this year on it. It was about 10% higher, but that's one data point. So it's going to be tough to tell until we start doing more projects, because it could just be that it took the contract. So our cost that we're receiving is actually installed costs. So depending on the project, it may be a harder project to install or less difficult. So we kind of got to see over more years to see how much more it is. This year was about 10% more than normal, but it may not actually be more because we may have had to pay more for the installation. It was not the material cost that was the difference. So it'll take a little bit more time to give a good answer on that.
Okay.
Yeah, thank you.
Did we answer all the questions so far?
We did get one more question there.
Okay.
And it is, have you noticed contamination in SSOM compost mixes or alone?
From what we've used, we've only used it 1 year, so we haven't noticed it in, I mean, the soil that was coming in, it looked really good. It was, even the contractor had mentioned it to us, like, this is premium topsoil. I mean, because it was blended, it was brought in. It looks really good. Now, as far as testing it for contamination, that wasn't done, but over time, I think, you know, we'll continue monitoring it. And I don't know if I answered the question or not, I guess.
I think you did. I saw another question here, and it seemed like that one was really a good question to ask at the end of, for all the panelists, and that is, can you condition already vegetated areas with compost? And I think there's almost every panelist will have some kind of a comment on that. So why don't we take note of that and save that one to the end. There's one more here. Could you design your specs to price with SSOM compost and without, so as to get at the price differential, or would this be counterproductive to your purpose?
So for us in road projects, it would cost way more to do that than the benefit we'd receive. A lot of our road projects have 200 items, and every time we take an item and we do an alternate to kind of see that difference, it costs a lot in design time and spec writing and such items. So the amount of time it would take wouldn't be worth it. Now, if it was more of a specialized project that only did the landscaping, I think it would be worth it. City of St. Louis Park is really dedicated to the environment and sustainability. And even though it is going to cost more, I'm thinking over time, there's so much of a push for the benefits of it that even if it costs more, we would do it anyway, just for the benefit we receive.
And I just noted that we have another question about providing test data. And I think that we would like to hear that from all the speakers. So why don't we hang on to that until we get to the end? Because Greg, I'm sure, has some comments on that, as well as St. Louis Park and probably Chuck as well. So it kind of crosses all of our speakers at this point. All right. Great questions. We're going to move on to our next speaker, which is Chuck Joswack with Specialty Environmental Technologies. The title of his talk is Food for Thought, the Necessity of Organics and End Markets. Chuck is the sales manager for SET, while helping oversee the daily operations at the 6 main composting processing areas and transfer stations. They operate around Minneapolis and St. Paul metro area. He, for over 20 years, has helped develop and educate others on diverse uses and opportunities for compost so that it can be looked at as a resource rather than just a necessary in our current diversion system. Knowing that different feedstocks and processing systems will provide finished composts that are not always equal is key to operating a successful program. Markets for those finished compost products can be challenging if we choose to look at compost as a generic, all-encompassing product used for every application. So I'll bring up Chuck's presentation. And let's see if I can do this. This seems to be a challenge every time I try to do it. Let's see, share. Wait. Okay. Yes, it does seem to be a challenge every time I do this. And here we go with Chuck's presentation.
Hello, everybody. Thanks for joining us today. My name is Chuck Joswick, and I work for Specialized Environmental Technologies, a Minnesota-based composter operating multiple processing and collection sites in the Twin Cities metro area. Today, I am going to try and get you to think about why we need specifications written for compost. To write a specification using compost, you first must determine the main objective of the project and understand the materials you have access to. Failure to understand the compost materials will put the project in jeopardy, and the long-term goals of diverting that material will suffer in the end. I'm going to discuss the importance of choosing the right compost to design your specifications so that we don't go down the wrong path and use a product nobody wants to work with in the future. I will quickly give an overview of what compost is for those unfamiliar with the actual definition. Ask you to reflect on your reasoning or goals to write a spec utilizing compost. Talk about barriers to processing and siting a facility to understand why we need specific end use opportunities. I'll go over pricing and value a little, and then go over best uses quickly. With end use challenges and the future of organics. I really believe that the opportunities for compost are so great that if it's done right, we won't have enough compost to get into all the possible markets out there. But we do need the help and support of those willing to think on a bigger scale rather than having the mindset of, it's just dirt. When you look at the possible systems that will help with sustainability and possibly carbon drawdown, compost plays an important role in many of the scenarios that can help the earth and fix other issues we face today. Why do we need to know what compost is? For years, the term compost seems to be used as a pretty generic name for any decomposed organic matter. There are many reasons composters go through processes to get the material that is beneficial to plant growth. So is it fair to say anything that looks like black in color and has a consistency of soil, that must be compost, right? Probably not. Unfortunately, due to the lack of industry knowledge and compost uses, most seem to feel this way. The longer I do this, I feel that many believe this is just something they are required to do. So how do we make it something they want to use and can't imagine doing it any other way? After being in the horticultural and erosion control industries for well over 20 years prior to this, dying plants and insufficient seeding outcomes were always one of the most frustrating issues for those trying to wrap up the project and close it out to get the retainage. So what did they do when something failed or died before closeout? Most of the time they blamed it on the soil. I changed to a believer in the importance of healthy soil when I saw results and put money in my pocket. So ask yourself, how and why would someone want to differentiate composts? I mean, different feedstocks or ratios of those feedstocks all give the same end result, right? Compost uses and finished properties must all be the same, correct? Process to make it. They're all the same, aren't they? How it should or shouldn't be regulated. They all must not be too different in the eyes of the regulator, manufacturer, end user, right? Absolutely wrong. Feedstocks will have different properties, CN ratios, water content, surface area, and will need to be adjusted accordingly for optimal composting levels. Just like soil is different on how it performs based on the levels of sand, silt, clay, and organic matter, the finished compost will have different maturity, nutrients, organic, carbon levels, and particle size affecting it how it will perform. These need to be taken into consideration when designing a spec because they can change the results you are trying to achieve and the costs of the finished material. The final finished product will have different properties based on those feedstocks, like we said in the last slide, as well as how to screen for particle size. What may be fine for tilling into a roadside application probably isn't the same for someone growing vegetables or bagging the product for retail, or someone top dressing an athletic field instead of trying to control erosion on a one-to-one slope. How it's processed will play a part in its end-use market. Do you want a product that is still hot and still breaking down, or are you okay if it has pathogens or heavy metals? Killing weed seeds might be high priority for some and not for others. Certain amounts of contamination like plastic or glass may be acceptable for some and not others. Getting that material to its final stage can be a big factor in the cost of a product. Odor issues with certain processes may make the logistics of where and how you process more difficult to get that product back into the markets. Then, is the maker of the compost someone who just piled up a bunch of leaves or brush on the back 40? Or are they permitted to manage that material, keeping safety of its employees and the surrounding community in mind? Do they manage for fire prevention or erosion or control and stormwater runoff? Are they being held to an even higher standard of contact water management to protect the environment from possible pollutants? It all makes a difference in the end markets. So just because it's black in color doesn't mean it's compost. Not all compost is created equal. So set your goals and define the purpose compost plays in reaching those targets. This is a big one. Are you targeting pollutants, capturing food, maybe trying to prevent erosion? How about sequestering carbon or growing a healthy plant, trying to feed the world? Design your specs to accomplish the task in the most economical way. The MPCA and state have set a goal to divert 75% of the waste stream here in Minnesota. So diverting food along with as many compostable items as possible is key to their success. Unfortunately, with that comes a significant opportunity for trash that is not compostable to enter the compost site. To make the system work, they must give value to the end product they try to divert by developing a spec and a market for a product that will have some sort of contamination, or they must choose to eliminate the contamination first before it gets to the composter. Next, you might have a PLA plastic or compostable product manufacturer. They may have a goal of selling compostable items to the masses, but they need composters to have success in taking their products. Their goal should be an easily identifiable way to make sure it gets to the compost site without other trash. Or they can help with designing and promoting acceptable end markets that can handle a little contamination. Otherwise, a composter will not allow those compostables in the system. Pretty easy to tell the difference in the two pictures here of compostables and non-compostables, right? This is about how much time a composter may have to accept or reject a load when volumes increase. A city or farmer might have a goal of being more sustainable long-term and want to close the loop on organics, or conserve water aquifers and reduce the need for pesticides and fertilizers. Engineers may have a goal to combat a specific job site problem or need. Haulers look to save costs all the time instead of landfilling materials and help meet goals of the state or county. But ultimately, the composter has a goal to stay viable and have outlets to move the products they create, and will need to look at the most profitable ways to do that and stay in business. What is your incentive to buy a particular compost? Like they say, if you build it, they will come, right? Does collecting a certain feedstock assure an end market for that material? Heck no. While governments make policy to divert materials, why are there no others joining the movement and opening SSO facilities all over the place? I'll tell you why. Money has a big thing to do with it. And a lot of times some of the nightmare scenarios and permitting issues that come along with it. How do you turn something like this picture into value and compete if no one else sees value in the end product to begin with? Ask yourself that. I typically see three main scenarios that happen in Minnesota. You have a composter who wants to open an SSO facility to help manage the problems of food going into landfill. They're required to jump through hoops to protect the environment and are willing to do that because they want to make a product beneficial to the environment. This is a very high cost system to site manage it properly. These systems take much more capital investment and space just to run them, and probably have the most difficulty in the end moving the product due to many factors beyond the composter's control. Next are yard waste facilities, which take less effort to get permitted and operate with minimal restrictions. Processing Something that looks like compost is much easier with less manpower, and there are not a lot of parameters that the end product really needs to meet a lot of times, making it much easier to move the material no matter what the feedstock is. It takes less cost to start up, but a little work to properly site and manage a facility. However, the markets are fairly abundant for a lower cost product in the end. Lastly, there's recently a large group that is just taking the material without anyone batting an eye. They don't have permits. They manage any material that will make them a quick buck and get by with people not questioning them. Somehow they enter the markets unchecked and tend to be accepted because the purchaser is almost always driven by finding the lowest price, especially if they don't know why they are buying in the first place and are just doing it because someone told them it was required. The compost then holds no value. Which system would you choose if nobody really cared that much about the end product or its properties? Pricing a compost is also difficult due to the lack of knowledge about the product, the many different feedstocks, and the perception that the material should be free. Unfortunately, some public operations choose to just give away the product after it sits a while, and some contractors do the same. They just get rid of it when it looks black. I made the mistake of trying to add value to compost across the board from our yard waste sites to help save our food waste facility that was struggling moving end product due to some contamination. In doing so, I took a product that was better and cheaper to make, yard waste, and showed the benefits of it causing a spike in our sales and creating a demand for it and increasing the price of it. It also opened doors for a lesser desirable product that cost more to produce once I ran out of the good stuff closer to the projects that were happening. Unfortunately, my own subsidizing of a system is now failing due to the sudden surge in those making the easier yard waste material or processing covertly and causing prices to reflect this. While some folks are content to pay $35 and up on decomposed plant matter like peat from a peat bog, they're crying at having to pay $8 for compost that could have just gone to a landfill that's virtually the same. So what is the true value of compost? Like I stated earlier about becoming a believer, when I added up the lost revenue due to buying replacement nursery stock and then the labor to replace it, including the cost to haul out the dead material, I would have been able to pay almost $50 to $60 a cubic yard for the amount I needed if I looked at it from a different angle, and I still would have come out ahead. Even paying more if I accounted for the lost revenue of a crew that was busy doing replacements or fixing seating and sodding when they could have been installing new work. I was paying $4 at the time, 20 plus years ago, for a really good finished product from this company actually that I work for now. So it was a steal and a no-brainer. Compost now had a value to me, and it went into every project I had, period. So what is the compost worth if an SSOM composter closes its doors due to the inability to cover costs and turn a profit processing food, or they are unable to get the product off their site after composting due to contamination? How much does it cost the city or state to redo projects that failed due to poor soils on a project? Or how much does it cost to add treatment systems when the whole project could become a big sponge by adding organic matter to the surrounding soil to begin with? How much is carbon sequestration worth to reduce global warming, or sustainable regenerative farming systems instead of killing our soils and wasting water? I know farmers who have said it's worth as much as $24 to $30 a cubic yard in their fields due to the savings in watering, fertilizer, and increased crop yields at times when fertilizer was more expensive. Unfortunately, it's more difficult to work with the volumes they need, and they don't always want contamination or possible weeds getting in their fields. Most of them tell me it's because they bought cheap stuff from someone not properly composting. I also have a previous customer who fails to understand that the $2 savings per yard from a guy who is screening out wood fines and calling them compost is the reason he has almost been doubling his fertilizer costs the last few years. But hey, he's saving $400 on 200 yards of compost he buys every year, right? Further understanding of the different types of compost you have at your fingertips will help with the best uses for that material. If it has a few pieces of glass or plastic from your food collection program, it may not be the best to top dress a soccer field with it, or put it in a bag to sell at a home improvement store, or sell it to a potato farmer down the road. A roadside application, mine reclamation, or fixing the subsoils of a construction project might just be a better fit. A more coarse material mixed with smaller fines could be ideal for a steep slope that you need to protect from a heavy rain event and get vegetation to grow quickly, while a real fine material can pull out and trap 95% of the contaminants from oil or heavy metals from roadside runoff. In Minnesota, there are specifications out there for a handful of different uses, but many of them point to just one of 3 fairly generic options for compost use. These may not be ideal for all applications and may not take into account the other goals you may be looking to achieve. It is really up to us to understand the best use of a material based on its characteristics, or to define specific materials for certain applications. The challenges with specifying the end use of a compost product will be difficult to overcome without some changes in how we look at compost. If the market dictates the ultimate decision on using compost is based on the cheapest price rather than performance, or maybe the ambitions of another program it supports, the industry is doomed from the start. People will continue to ask why we are doing something that isn't helping or working when it wasn't properly composted and put in the right situation to begin with. Just take a look at the difference between the growth of wood-based compost versus chicken manure here. Is it better to know which one you are getting? Challenges like timing or feedstocks or demand for certain types of them, along with storage to mix properly throughout the season, odors, temperature, moisture control, weather, contamination are all going to come into play for composters as challenges. Instead of lions and tigers and bears, oh my, which I understand can be more of a concern at some compost facilities than others, not necessarily ours. COVID and PFAS and microplastics, oh no, we hear about them every day. These are the challenges to the systems we have in place right now. Pathogens can be in the composting process. However, if done properly, they can be managed and eliminated under the right composting conditions, keeping employees and end users safe. Most, we even have effective treatments for. Some we have little knowledge about and can cause concerns about our operations, like COVID, which still today poses challenges across the country with waste streams. As an end user, you should be confident that you're not sending out something that could make someone sick. PFAS and other persistent compounds are ubiquitous in the environment and are still used or replaced with shorter chain versions we don't know much about. Many are allowed. However, the costs must be absorbed by the landfills or the composter dealing with them today because they pose an environmental threat. How could an SSO composter ever compete with other systems unregulated out there with these costs that they incur? For these reasons, many composters discourage the collection of compostable products, not because they contain PFAS or PFOS, but because they mask the garbage containing those chemicals that often accompanies the good compostable materials. Microplastics are another concern. We see an awful lot of finger pointing at composters or people spreading sewer sludge that microplastics are in that material and getting spread around the environment. Are they the problem? Or how does it get into them in the first place? Most of these issues, including persistent herbicides, stem from others and fall into the composter that has to deal with them and the costs involved to do that. Like I said before, many of the composters want to improve the environment, so we try to take the necessary precautions to do it right. That typically starts with the first step of becoming a permitted facility. Then there are EAB, noxious weeds, jumping worms, and other invasive pests that add additional challenges to compost facilities. We have it all. When specifying compost, know that it came from a facility that goes through the proper processes to deal with these, and that should help you sleep better at night. I also look at things like jumping worms that are found on the surface of the soil and fairly shallow in the soil, then wonder why we don't regulate the millions of yards of soil moving around the state for construction projects. I'm confident it won't live very long in our compost piles if raked up with the leaves, but a soil pile, I'm not so sure. But even noxious weeds can be a concern at a yard waste site, or possibly the land clearing companies hauling out truckloads of underground wood waste to sites with emerald ash borer in them. To sum this up, start with gaining knowledge about compost. Who's making it in your area? What feedstocks are being used? Do they test? The STA gives a ton of data points to look at when determining if it's a good material. Are they a reputable facility following certain guidelines by your state? Are you making sure they are protecting the environment and making a material that is beneficial to your project in the end? Next, determine your goals for using it and ask yourself if you can write a spec based on the products you have to accomplish that goal. Is this the best use for the product you have on hand, or can you go back to the composter to adjust some of the things they're doing to give you a product you may need? Look for other state specs or check out companies like Filtrex or the USCC and its chapters who have put together these specs and guidelines for the materials. Check to see if the budget will allow for it to be incorporated in your projects. And if not, do you need to do some of the other things now because you're using compost, or could those things be eliminated possibly? Work diligently to make sure the challenges composters are trying to overcome are addressed. Remember, this isn't some multi-billion-dollar company with the resources to handle all of these things that have no control over that. One employee dealing with the time and efforts to properly site and manage a facility along with following the rules to protect the environment is enough to add a few dollars to your cost per yard of compost material made in the end. So be sure it's a level playing field that you're working with. Bottom line, the future of organics can look positive if we take the right steps now. And it starts with your help being here today. And by writing the specs to utilize the proper composted material that we are trying to keep out of a landfill and make it beneficial to the environment. We don't need SSO facilities shutting down. We need expansion to go along with the goals driven by the states. But we also need end markets driven by those goals because they will not be successful without them. Thanks a lot for your time. I'm looking forward to any questions you may have. Have a great afternoon.
All right, thank you very much for that. And we are now in the open question session, and I want to go back to the couple of questions we got earlier. How can you recondition an existed vegetated area with compost? And if you can do that, how would you do that? And we can have all of our speakers turn on their cameras and take questions, take these questions. So who wants to go first?
I could, in Chuck's presentation, he had showed a picture of a top dresser that it's Eco-Lawn is one applicator, one equipment company that has varied size of compost top dressers. And that would be a way to go over the top of existing vegetation.
Would you want to do some core aeration or something like that?
Yeah, check it for soil compaction. Yeah, that's what we usually do, like that wire flag test. Go through, check it to see if that needs to be amended. But it just, depends on the type of vegetation there. But
yeah, any other comments from speakers?
Well, I think you're absolutely right. Anytime you can loosen up the soil structure and get that compost down in there, that definitely is going to help the situation in a much faster period of time. But if you can't do that, just adding organic matter in the compost to the surface of the soil is going to actively put that biology there. And it will take time, but it will eventually work itself down into the system and into the soil structure beneath it. So it can be done either way. Blower trucks are another really good way of doing that. They have these trucks that actually have a 4-inch diameter hose that come off of them. And if the compost is dry enough, they can actually blow it through that hose and put it pretty lightly over the surface of the soil or the existing vegetation that's there as well.
Okay. Any other comments regarding that particular question? Seeing none, another question that really kind of applies to everybody is test data. When you spec the compost, do you ask for test data? And Chuck mentioned it, it's STA, which is a broadly accepted testing program or test methods that are used in that program to characterize compost. So go ahead, have at it. I see Greg nodding his head.
Yeah. So we do require test data from the vendors, what it's coming from. We don't require at this point the STA. Yeah, we're probably going there because we have accepted other third-party testing, but yeah, we trust Chuck's the most.
Yeah, and he's STA. He's an STA program.
Yeah.
I think
So,
it is important to get that testing data because we've seen some that's questionable and they finally turn it over, and we can see, what is being sold as MnDOT 3890 grade 2 compost with super low organic matter, in it. It has a lot of filler and and whacked out pH, and in some cases by the time they drag their feet providing that data, and then it's already on site, then. So we've tried to really dig in a little harder on, you got to give us this before it's being trucked into the site. Because then it also, for us, it changes the calculations on the number of, or how much volume of compost they need to bring in to hit their 5% target. So we can just put that into that calculator. And then usually by that time, we're like, well, you're going to need 2 times or 3 times as much compost. And then they look at the total cost and go, okay.
Yeah, it changes that quite a bit, I would imagine.
Yeah.
How about you, Joe? Do you guys require any kind of testing or for your compost?
You're on mute.
You have to unmute yourself. There you go.
So at this point, we require testing to hit the 3890 spec, but we are also limiting the sources to 2. We only allow SET or Shakopee Midwakaton. So being we're limited to those 2 sources, the chance of us not meeting the testing is pretty low, but our testing does need to meet the 3890 spec of MnDOT.
Okay, there you go. We have some more questions here.
And Jenny, can I kind of follow up on that as well too?
Sure.
Those that are designing the specs have the ability to write that in there and police that. And I think that's very, very important. It's up to you guys to make sure you're collecting that test data. The 3890 spec is a pretty basic spec and a pretty very limited number of things that they're testing for, which is fine. What's nice about the STA program is the STA program does dive into it quite a bit more. They are looking at pathogens, they're looking at heavy metals and things like that. And so that's why we've always kind of gone down that path of the STA program, is because it's more data for you to look at, and it's so you guys can understand that you're getting something safe back into your project is what it comes down to. So it's just taking it to the next level.
Oh, you answered this.
Chuck, can you explain STA for those on the call who may not know what it is?
Sure. The STA program is the Seal of Testing Assurance program. It was started by the United States Composting Council. So it's kind of designed to give you the best picture of compost that you're trying to test and the data that you're looking for. Yeah. It's a fairly expensive way to go about the testing process, and they have certain parameters that you have to meet. And I believe, Jenny, you can correct me if I'm wrong here, but or Linda, I know she's on here too. I believe one of the first things that they ask for as an STA program participant is whether or not you are permitted in your state or county.
Yes.
And so it's a good way to know that you have a permitted facility that is using or is creating the product.
Yeah. And the program is based, actually, it started here in Minnesota, where the samples were taken, and the University of Minnesota developed the modified soil tests to be used on compost, and that it is actually a standard set of test methods, not necessarily giving the parameters that you must fall into to be a compost. That really gets back to the issue of specifications for the project. And so getting that test data allows you to look at the specifications you want for your particular project, because it'll vary, and give you accurate information about that, because they are tried and true methods been used for the last 25 years. So if you really want to know what you're getting in your compost, STA is one of the things you really want to have as part of it. Nathan, let's see, he's commented that the 75% organics recycling goal is only applying to the metro area, and he wants it applied to greater Minnesota. So there's some work for us to do, I guess, if we want to go to the legislature and expand that. Let's see, does SET accept any MRF fines or other non-food industrial organic wastes? If not, would SET consider processing these potentially higher contaminant wastes in the future? I don't know what a non-food industrial organic waste might be. I'm not sure what that is, but want to take a shot at that?
Currently, we do not, and I don't see that being something that we will get into in the future. Ultimately, what we're trying to do is create a good product in the end that we can put back into the environment. You know, it's something that we've talked about, but I don't know that we'll go down that path at any point in time currently.
And then the next question is, what should a contractor ask from a compost provider to verify the quality of their compost? And that would be testing. You need to have, if you want to really know what you have, you need to have testing. So why does MnDOT buy all of SET's compost and spread it on roadsides to sequester carbon? Why doesn't MnDOT do that to sequester carbon and offset the impacts of fossil fuel burned on Minnesota roadways? Well, there's a question. I don't know that any of us can answer. Dwayne is on the call and he might be able to, but I don't know if he can talk to us or not.
I like the concept of it.
Yes.
You know, and speaking to one of Dwayne's comments that he made before, I think this is, he made a key point there. Mixing 50% topsoil with 50% compost, the 50% topsoil being that on sites. I think those are all ways that we're all looking at to try to help with a lot of the issues that are out there. Anytime you can not have to move that soil off the site, you're only going to get, you're helping the environment just by not doing that. And compost has the ability to, you know, fix almost any soil type that you have. So just adding that compost in and mixing it in, kind of like what Greg's doing, it does have the ability to physically, chemically, and biologically change that soil structure in a good way. So it's a great way to try to help, you know, offset some of those impacts that we have on the environment as well. But I would definitely be open to having MnDOT buy it all.
Let's see. Chuck, how many grades or blends of SSOM compost does SET produce?
So SET produces the class 1 compost, which is considered the grade 2 yard waste compost and or SSOM compost. So we actually, depends on what our facility is. 3 of our facilities actually just do strictly yard waste and are permitted only for yard waste. The other facility is an SSOM facility, and we take SSOM from different municipalities and different programs that are out there and process that food with yard waste. Now, when it gets into like some of the blends we do, we actually also do a lot of the soil blends. The 3877, I think Greg had mentioned before, are a lot of different mixes utilizing compost and sand materials, compost and topsoil materials and things like that. And we do a lot of those as well too.
Okay, there's a question here. Does the composter have to provide testing data that would verify contamination levels? I'm not exactly sure. There's so many different kinds of potential contaminants that I'm not sure if they're talking about chemical contaminants, physical contaminants. I'm not, it's not clear to me, but maybe someone wants to take a shot at that.
The class 1 compost in Minnesota is you're allowed up to 3% contamination of plastics, glass, sharps, things like that in it. And that's also, I believe, the MnDOT spec as well has allowed that. One of the reasons we do the STA program, though, is to check for those other contaminants that they would be looking for, but that is not required in the MnDOT specification. I believe possibly pathogens in the MnDOT spec. I'd have to look again.
Levels of constituents. I'm trying to, this question here, this is a really interesting one to me for a variety of reasons. My understanding is that STA requires a specific test method. That is correct. It does not define, it will tell you the organic content, the nitrogen, phosphorus content, various things, heavy metals, things like that. But it doesn't say that it's good for the use potentially that you are trying to use it for. So the second part of the question is, do you have any recommendations of sources that provide acceptable levels of various constituents in compost? And some of this is just going to be based on the soil types you're working with. It will vary. What I can say to this is that the Compost Foundation, that is a national organization that I chair, is developing specifications. And I think this is one of the things we're looking at, and I can get back to you because I know who this is. And I want to ask that question because I think it's a very good question. It would help people if they could have some kind of a chart that might give some guidance to people specifying the compost use. Currently, really all we have that I can think of is metals in the rule. It will give you, it's an environmental standard. It isn't really a use standard, and you can only have a certain up to a certain level of metals, different types of metals. And if you exceed that, then you stray into the area of hazardous waste. Now, none of the compost that we have, yard waste or food waste, has ever gotten close to that. But that's the only standard that I know of that kind of sets parameters to the types of constituents in a compost. Anybody else got any other thoughts on that? Any of our speakers? So I will definitely get back to you on that. So we have a comment here. From one of the composters in the areas, if someone won't provide you with the test data, then it's probably because, one, they don't have it, and if they do, they didn't pass the standards, or it shows that it's really not a quality material. So you need to be cautious. And I think Chuck covered this quite a bit. Again, it goes to the asking if they have a permit, if they're permitted by the state, number one, and number two, are they testing their material so that you can see what they have. So to some extent, it's a consumer beware and ask the right questions, basically.
Actually, Greg and I got to meet down on a job site at one point in time, and there was a remnant pile of the compost that they were putting out, and he was having some troubles getting the test data from that person that supplied that. And I went to stick my hand in it and almost burned my hand. I could hardly even touch the stuff. I could feel the heat radiating off of it. So obviously that test data would probably never would have passed in the first place.
Yeah, it would pretty much destroy anything you tried to grow in it, because it's still.
And we do have a question for Greg. That question is, did you develop the calculator to determine if they've met 5% organic content? And is it something that can be easily adapted for others?
Yeah, so I didn't develop it. We got it from, I think it was through soilsforsalmon.org out of Washington State. So it had been all developed out there. They've been doing this kind of thing for quite a while. So we took their Excel spreadsheet and we just use that. I tried to find it the other day, just doing some searches. I couldn't come across it, but I didn't spend a lot of time doing it. But if anyone wants to, send me an email and I'll email you the file. gthompson@cityofelgan.com.
Okay. I think we've covered this one. Does a composter have to provide testing data that would verify contamination levels? They don't unless you ask them for it. Should be part of your specifications, actually, that you get that if you're really interested and would like to have that. What ballpark of values is everyone seeing in compost, whether in a buyer or in a seller's shoes? Anybody got any thoughts on that one?
I guess I can say that you're probably going to find on a retail basis, you're going to be in the low to mid 20s range on a fairly decent compost material. On the kind of construction side of things, those types of contractors are going to see anything from $7 to $8 a yard on the low end to $15, $16, $17 on the high end for a decent compost. Right in that ballpark, if that helps and answers the question.
Okay. If it doesn't, they can ask us another one. Let's see. Do you believe that less stringent specs could or should be used for roadside? That's pretty subjective, and most of the time you don't get to make that choice. The DOT makes that choice, or the city, because they also have roadsides. But generally speaking, at least in our state, the DOT sets those specs. Should they or could they?
I think
I don't know.
The big thing you're going to find is that with less stringent specs, you're going to get lesser quality product typically coming into those projects, and that's what kind of what I was trying to say is, anytime you have a lesser quality product, you run the chance of a project failing. And if it fails time and time again, why is anybody going to use compost in the long run? We're trying to benefit the environment. So I don't mind more stringent specs. Let's define those specifications based on the project. So yes, there may be projects that you could get away with a less stringent spec, but there may be a project where you might need a very detailed, really tight specification because you're concerned about phosphorus runoff into a water body or something like that. That could be a big concern or something. So, I think it's looking at your project and defining how strict you need to be on that spec.
And Joe, you do road projects all the time. What are your thoughts on that particular question?
Basically, MnDOT defines what's needed in the 3890 spec. They're typically more of the minimum type spec. So as far as going below that, I wouldn't recommend that. I'm not saying that they couldn't do it, but you're just not getting the value out of what you're trying to get. You're not getting the complete compost value out of it if you're using a lesser spec.
Yeah. And typically,
I would like to jump in here. I'm just going to launch the poll here. As people are answering questions, just feel free to take that poll. Thank you.
Yes, thank you. That's the last poll. So, and this is one of the more, for me, it's we're asking what kinds of topics you want us to cover in future webinars. So for the Market Development Committee, this is a pretty important poll. We want your thoughts, and so appreciate your answering the poll. We have a comment here from, hi, Julie, a person from the Chicago office of the EPA. Ohio EPA has a constituents list for compost. So to the other person's question, that may be a place that we could go to look for something like that. And I'll see if I can I've got a contact. I think I still have a contact in Ohio EPA if they haven't retired. And I can see what those are. Or maybe Julie, if you have them, you could send them our way. This next one, I've heard composters say in the future they may require cities to commit to purchasing compost if they want to deliver SSOM from curbside programs to the local compost sites. Do you see that being part of the picture, and how do you envision it would work? How much do they have to buy? Does the city buy it directly, etc.? Long question. So are either of your cities, well, we have one composter on here. Is that something that SET has talked about? Do you know?
Well, I think it depends on what happens here in the future. One of the things that, you know, in working with St. Louis Park that's been great is they've been trying to complete that full circle. And I think that's a very important way to do that. It is definitely more difficult to move that SSOM compost product in the end. So it's tougher to get it into markets. Like I said, we can't hit a lot of the avenues that we hit with our yard waste products, like top dressing ball fields and putting it in bags and things like that, because there is the possibility of more contamination in that material. Yes, I do see that being part of the program, mainly because there is a limited capacity for processing SSOM material currently. And so as a composter, if you're having difficulty moving that end product, you're going to want to work with somebody that tries to help work with you, because we don't have all the resources that we need. Remember, this is like, it's dirt cheap, right? We're not making millions off of this material. So all the help we can get by cities kind of trying to close the loop and bring it back into their city, we encourage that as much as possible. And if we have somebody that's working with us that needs that pad space to process that material, we're going to be more open to giving that material, giving them that pad space to process their material, because they're ultimately helping us move it off the site in the end. How do I envision it working? I think the tricky part is kind of trying to determine, I've done some calculations. I would say that for every ton of material that you bring to us, by the time we mix the feedstocks and the carbon sources with that SSOM product, and bulk it up with that, run it through our process, and get a finished product in the end, I would say that for every ton you bring in, we probably create about 1 cubic yard of material in the very end, after bulking it with a couple of cubic yards of leaves and wood fiber material and that carbon source that we've got. So it's a pretty easy calculation. If you wanted to say St. Louis Park brought me 100 tons last year, they should use 100 cubic yards back in the system if you wanted to do a 1-for-1. Not saying that that's got to be the case, but that would be kind of a way to encourage that, I guess.
And I would say, I think part of, I agree with, what Chuck is saying. There has to be some math there and figuring out how things work. I do also think fundamentally, part of what we're doing now is just trying to switch the mindset of, our colleagues within the city, other departments that are using compost, and helping folks understand the value in using compost, and that continuing to just expect to get the stuff back free because it's being our organics that are set aside by residents and put out at the curb are being processed by a composter. We should just get it back, switching that free, low value mentality that that our colleagues might have, to understanding that it is a high value product and it is something that we should be paying market rates for is part of it. So I think those are hard questions to answer as far as exactly what it would look like and how it would work, putting it into a contract. And that's really why we're trying to test it out in different areas to help change people's minds, help actually see the results, and that'll make things, I think, easier when we start to have those conversations, when we're looking at new contracts in the future. So.
Okay. Next question is a very interesting one. And we have talked about this at the Minnesota Compost Council and kind of gone round and round. And it's to all the presenters. Do you support pricing / markets for soil carbon credits to drive the use of cover crops and compost applications in projects? Anybody got any? There's, I guess I'll start. And that is, there's a growing amount of information regarding using compost and accumulating carbon credits. But I don't know that we're there to be able yet to really require that. But there's been the Marin County project's been going on for quite a long time and has quite a bit of information. There's some other ones too, but maybe presenters have some thoughts on this. No? Yeah, no? Okay.
I guess, yeah, I'd have to see what it looks like and what the program looks like, because I can see it. I definitely think it would be a benefit in the long run to help the compost industry. I just don't know that, like I say, if you really go through and do this, if there'd be enough compost out there to really help that and do that currently. Maybe someday, but I could support it in the long run if it were the right program put together.
And I'd have to say, I think that the Minnesota Compost Council is it's thinking about this and trying to figure out exactly what angle or how to do this. Eventually we may well go down that road, but right at the moment we're not there. We're still in the how do we do this kind of thing. Let's see. Where are we? Does a composter have to, we've asked this to provide verification of contamination levels. And most, in metals, you have to provide metals, but how about pesticides, herbicides, PCBs, PFOAs? Well, PCBs actually is in the Minnesota Pollution Control Agency specs, and they have to be tested for it. And as far as I know, PCBs was only found in one case many years ago, where they took some mash from a commercial facility and it had a leak and it had PCBs in it, but it's never shown up in any other testing. I don't know about any other type of testing. Has anybody got any thoughts on that? Chuck, have you heard of anything?
Yeah. I have not. We do some herbicide testing and things like that I think it's twice a year that we do that, just to kind of do some checks to see if there are any of the persistent herbicides in there, but we're not required to. It's just something that we do.
And I know the U.S. Compost Council in the 2000s, we had clopyralid that was showing up, and it's a persistent herbicide, and they worked with the US EPA and the chemical manufacturers to have it at least be eliminated from materials that are used in yards. It is still, I believe, maybe our EPA person knows, but it is still allowed in agricultural uses. So composters have been quite wary about taking manure from farm animals because they use straw and bedding, and that's actually where it comes from. And so that's been an issue in the past. Aminopyralid is a cousin, and that also has been an issue, but again, it's been restricted in use, and so does not typically show up in yard waste compost and food waste composting, source separated food waste composting. It's not been reported in any of that type of compost. Are any compost facilities that accept wastewater byproducts, biosolids? Not in Minnesota, period. Fought that battle or tried to fight that battle with the staff at the Minnesota Pollution Control Agency when I was a staff person there, and it was a losing battle. So here we do not do that. They do it around the country though. Oh, and here's a website for carbon sequestration. So we'll have to check that out. Thank you for that. Let's see, we're getting close to wrapping this up. Minnesota compost industry seems to be focused on producing compost as a means of waste management. Is that the trend at the national level as well? Or are there areas where the focus is farming or manufacturing compost for the sole purpose of making a product? That's an interesting question. I think the state looks at it from the perspective of managing waste, but I think the composters look at it from the perspective of making a quality product that they can sell. Has anybody got any thoughts on that? I think I must have summed it up pretty well then.
Yeah, I think you did.
It's Linda. I don't know if you can hear me.
Yeah.
From SCC. Yes, I'm kind of in the background. But I did want to say that we are, through the Legislative and Environmental Affairs Committee, we're doing a lot more work around agricultural compost for agricultural use. We are actually making some comments on an NCRS practice standard that is potentially going to go nationwide for compost use for carbon sequestration on farms. So that is definitely one thing we want people to remember, that composting is not just a waste management tool. It is actually the product that we want to amend the soil and cure the climate.
Mm-hmm. And part of that carbon sequestration issue revolves around establishing a carbon credit system nationwide. Currently, it's only in selected states, and I think it's mostly the West Coast. And there was an effort in 2010-ish timeframe to establish a carbon credit system nationwide. It obviously didn't pass. So I don't know if there'll be more support politically now, 10 years later. One can only hope. But if that kind of a system were established, then farmers could, and cities, people who use compost could get credits for that, and be financially, have a financial advantage to it. But that's the kind of thing that, as I said, the Minnesota Compost Council has been discussing, but it's obviously far bigger than us. And so how do we, start to leverage that kind of thing? Probably the U.S. Compost Council is a good place to go. But we have a few minutes left. I guess I'd just like to thank everybody for attending. It's just amazing the number of people that we had. Thanking our speakers. They did a great job, very interesting presentations, and thanking the attendees for responding to our questions. We'll bring that all back to the Market Development Committee to discuss here in another week and a half or so for our next webinar in the three-series webinar series we're planning. And of course, we have to thank our wonderful sponsors for also being a part of this. You can see them all right here around me. They're local companies, local composters, and we've just had really terrific support from them, and we truly appreciate that. And I think with that, I'm going to turn y'all loose. It's nearly 4 o'clock, and we can go do whatever we do at 4 o'clock. So thank you all for attending. And again, thanks to our speakers and sponsors.
Thank you.
Thanks, everyone.
Bye.